When we're talking about energy in a nuclear reaction, what we're able to use is Einstein's equation for energy. E is equal to mc squared. However, we're not taking into account the entire mass of our atoms and reactions. We're looking at the change of our mass. As we're also dealing with atomic particles, which are extremely small, our normal unit of energy, the joule, is much too large. So what we are using is in fact what's called an electron volt. An electron volt is the change of energy of a single electron moving across an electric potential of 1 volt. And 1 joule of energy is the same as 1.6 times 10 to the negative 19 electron volts. So it is a really small unit to deal with. However, when we're dealing with small particles, it makes sense. So how does this relate to our E equals mc squared equation? Well, when we're looking at one atomic mass unit, that is equal to 931.5 mega electron volts divided by c squared. M is our mega, and that is equal to 10 to the power of 6. And c squared is equal to the speed of light squared. What that means is that when we're dealing with our equation E equals mc squared, our change in mass, which will be on the scale of atomic mass units, we can multiply it by 931.5, and we'll end up with mega electron volts divided by c squared, which, seeing that we're multiplying it by c squared in our equation, we get our energy from it. So writing that all out, our energy, which is in electron volts, which we're then changing to mega electron volts, so MeV, is equal to our change in mass, so our U, which we've also found that it is equal to mega electron volts over c squared. And we're multiplying it by c squared. So what we'll end up with is cancelling our c squares, and we'll have mega electron volts is equal to mega electron volts. When we're talking about energy for an atom as well, we're talking about two types of energy. What we have is either binding energy, or we have decay energy. Binding energy talks about how a proton and neutrons, which have masses of, will sum up, so the sum of the protons and neutrons will be greater than the atomic mass. Decay energy is similar to that of binding energy. We are still looking at the change in mass. However, they also release energy. Think about our beta plus and beta minus reactions, where we have an electron neutrino and an antineutrino. This is evidence that there is an energy change, but the same holds true for an alpha particle, where we have an antineutrino and an electron neutrino. However, the same thing applies to alpha radiation. In alpha decay, we don't have a unique thing looking directly at the energy like our beta, But we do have the mass of an alpha particle, which is 4.001506179,127 atomic mass units. Now we can find the energy. So the binding, again, is just looking at the difference between the masses of all the protons and neutrons compared to that of the atomic mass of the atom. And decay is looking at the change of mass before the atom decays and after it, where we can use the masses of the products and the reactants to determine the change in mass and give us our change in energy.